Thank you, sir, for enlightening the importance of National Science Day to the students. Dear all, the theme of this year's National Science Day is Integrated Approach in Science and Technology for a Sustainable Future. On this, we have arranged a talk by our today's chief guest, Professor Adimurthy, with the title that Opportunities and Challenges in Space Science and Technology for Future Explorations. I have the privilege to introduce to you to our chief guest, Professor Adimurthy. Dr. Adimurthy received his PhD degree from IIT Kanpur in 1973 for his work on hypersonic low-density flows over re-entry bodies. Following this, he joined the Indian Space Research Organization in March 1973. During the 5 decades of his professional career, he made significant individual contributions to knowledge in the areas of aerodynamics, flight dynamics, trajectory optimization, space dynamics, space debris studies, lunar and interdisciplinary mission design, and multidisciplinary design optimization. From 2011, he is co-editor of the journal Acta Astronautica of the International Academy of Astronautics. Dr. Adimurthy is presently ISRO Honorary Distinguished Professor. Earlier, he served as Professor Satish Dhawan Professor and Senior Advisor, Interplanetary Missions at ISRO, and as Associate Director of Vikram Sarabhai Space Center and Dean R&D of the Indian Institute of Space Science and Technology, Trivandrum. Dr. Adimurthy is the chairman of the Mars Mission Study Team, whose report of 2011 provided the conceptual design for India's Mars orbiter mission. A vision for future Indian solar system exploration is also formulated in 2017 by the Solar System Exploration Study Team headed by Dr. Adimurthy. He is also instrumental in submitting the 2021 report of the committee chaired by him for the generation of revised Indian atmospheric model, assimilating and quality processing 45 years of segmented observation data. Dr. Adimurthy is a fellow of the Indian National Academy of Engineering. He is the Vice President of the Aeronautical Society of India during the period 2008 to 2019. He is an academician of the International Academy of Astronautics and Senior Fellow of the Alexander von Humboldt Foundation, Germany. He is a Fellow of the Systems Society of India and the Astronautical Society of India. From 1999 to 2012, Dr. Adimurthy served as the Indian representative in the Inter-Agency Space Debris Coordination Committee and was twice the chairman of this international forum during 2002 to 2003 and also in 2009 to 2010. Dr. Adimurthy was awarded the National Aeronautical Prize in 2005. He received the 1997 Astronautical Society of India Award. In 2007, he received the Department of Space Performance Excellence Award. Dr. Adimurthy received the Padma Shri Award in 2012 for his contributions to science and engineering. He received the IAA Laurels for Team Achievement Award 2013 for Chandrayaan-1 at the International Academy of Astronautics meeting at Beijing. He received the biennial ISRO Outstanding Achievement Award 2014 and Indian National Academy of Engineering Professor Joy Krishna Memorial Award in 2016. So, friends, it's now time to listen to today's talk by Professor Adimurthy. Sir, I welcome you to start your talk.
Can you confirm if you can see my slides? If you can get my voice properly, can you confirm that?
Yes, sir. We are getting your slide on the screen, and your voice is also clearly we are seeing.
Okay, very good. Very many thanks. And it is indeed a great pleasure to be with you on this very important day. Indian Institute of Technology, Bhubaneswar, is organizing the National Science Day, celebrating in a very extensive fashion. And it is a great pleasure for me to be with you on this very important occasion. I also noticed that the Research Scholars Day is also clubbed today of the with this National Science Day. I consider it as indeed a very elegant idea to integrate the Research Scholars Day with the celebration of the National Science Day. I have gone through briefly the posters presented by the research scholars and the titles of these various posters that are there. And I find that they are of excellent quality with a broad diversity of topics covering basic sciences, and not only that, mechanical, electrical, metallurgical sciences, and more importantly, integrating humanities and social sciences and infrastructure development. The importance of multidisciplinary activities like this has been highlighted very nicely by the director in his very interesting talk. And once again, thank you all for inviting me for this on this occasion to be with you on this very important day. I also noticed that a lot of school children also may be participating here, and they are the future of this country. They are the future of this universe, and it depends on them. And therefore, I welcome them all to this very important occasion. I was very much fascinated by our Constitution of India. I think it's very unique that it puts scientific temper as our fundamental duty. It is not our right. It is our duty to have this scientific temper. It is written in our Constitution, Article 15A, item H, which talks about these fundamental duties. And it says it shall be the duty of every citizen of India to develop the scientific temper, humanism, and spirit of inquiry and reform. And putting this science in the forefront to our progress is very unique to our Constitution. I do not know, I'm not aware of any other constitution which highlights scientific temper. And what is this scientific temper? It is highlighted in the discovery of India. It is the scientific approach, the adventurous and critical temper of science, the search for truth and new knowledge, the refusal to accept anything without testing and trial, the capacity to change previous conclusions in the face of new evidence. It is very important. You should not say what I said yesterday was right. It should be right. If new evidence tells you that you have to modify your conclusion, this must be done. This aspect was highlighted by our director also. And the reliance on observed fact and not on preconceived theory, the hard discipline of the mind, all this is necessary. And this is necessary not only for the application of science, but for life itself and the solutions of its various problems. If all of us follow this thing, our problems will be less and the humanity and the universe will progress. Of course, there are many, today we are celebrating the National Science Day because of the discovery of great discoveries of Sir C.V. Raman. But while we respect the greatness of Sir C.V. Raman, we also respect the greatness of very many scientists who have contributed. And here I pick up randomly this is not the totality. It will be totality will be several times, many, many more people have contributed. I have put here Sir Jagdish Chandra Bose, Sir Sri Vishweshwaraya, and Professor Chandrasekhar, Srinivas Ramanujan, and Aryabhatta, and Gurga Koranaji, and Vikram Sarabhai, and many, many, many more people have contributed to the progress that we have made. And we particularly today, we pay tributes to the greatness of Sir C.V. Raman, and we already highlighted, he is best known for the Raman effect. And he observed in his voyage to Europe in 1921, he noticed the blue color of the glaciers and the Mediterranean Sea, and he was worried why this blue color is coming. And he carried out detailed experiments, and on 28th February 1928, he has announced the discovery of Raman effect based on a large number of experiments, a large number of things he has done in the previous years. And he has announced on this day, that's why to commemorate this thing, we are celebrating our National Science Day. And of course, he was awarded 2 years later, the Nobel Prize. But Raman was so confident of winning this Nobel Prize that he booked his tickets in July 1930 itself, even though the Nobel Prize will be announced in November. He did eventually get the Nobel Prize in 1930 on the scattering of light and for the discovery of Raman effect, but he has done many, many more other distinguished studies in the science. And so we greatly honor and greatly thankful for the inspiration he has given to this country. Of course, I'm representing the Indian Space Research Organization, and I'm going to tell you about the important opportunities and challenges of the space science and technology for the future growth of this country. And this is initiated by none other than Vikram Ammalal Sarabhai, who lived for a short time, only 52 years. And in this short time, he has achieved so much. He has established large number of institutions in diverse fields, and he was instrumental in establishing the physical research laboratory very young age in his 20s in 1947. And the establishment of the Indian Space Research Organization is one of his greatest achievements. And he has convinced the government that we need, a country like India needs this thing. And he was also the chairman of the Atomic Energy Commission. And therefore, he is a great person who has initiated all these things. And how he was able to do this thing, how he has become the great visionary. He said, we must be second to none in the application of advanced technologies to the real problems of man and society. It is in some sense reflecting the theme of the National Science Day today, this year's National Science Day. How was he able to do it? And I think this is because from his very young age, he was influenced by the universal thinking of the great people. And here is a photograph in which his family has taken with Rabindranath Tagore. And here, if you can see my cursor, here is the little Vikram Sarabhai, little boy here. From that time itself, he was going with the people who think universally. And when he was 16 years old, it was Rabindranath Tagore who has given him in a introduction to go to the Cambridge University and study. He said, Rabindranath Tagore has said, here is an young man with keen interest in science, and I am sure a course of study at Cambridge will be of immense value to him. Not only to him, it was of immense value to the whole country. I know him personally and his people. He comes from a wealthy and cultural family in the Bombay Presidency, and he is a fit and proper person for admission to the university. That's how Rabindranath Tagore, has a great poet, has introduced, and therefore, from the childhood, he was inspired by the universal thinking of the Tagore. I will tell you a little bit more. So, but as I say, we all come from our childhood. Whence come I? I come from my childhood as I come from a homeland. And this is the growth of Vikram Sarabhai. And all of us also in our childhood, the inspirations we get make the future life and the future contributions to the country. And therefore, I value the childhood very much. And I was surprised in recent years. Recently, I came to know, even though I was a great fan of Rabindranath Tagore, I never knew his excellent thinking of the science. He has in his life in 1937, a few years, 4 years before his death, and when he was 76 years, he has written in Bengali a book called Vishwa Parichai here, and it was translated into English also later on. And the book has 6 chapters: the world of atoms, the world of stars, the solar system, the planetary world, the Mother Earth, and conclusions. And I have gone through all these things very carefully in the English translation, and I was fascinated by the profound and inspiring essays he eminently written, and it reflects the Tagore's lofty perception of the unity of science, literature, and philosophy. This is the integration not only of multidisciplinary integration of various fields of science and engineering, but the multidisciplinary integration of science, literature, and philosophy. This was reflected in the discussions Tagore had with of Einstein. You may be knowing that Rabindranath Tagore and Albert Einstein met about 3 times, and the first time they met was in Germany in 1930. Both had won the Nobel Prize by that time, Tagore for literature in 1913 and Einstein for physics in 1921. At the time of that meeting, a gentleman called Dmitry Maryanov, a relative of Einstein, has manually recorded the discussion. That time of technology is not that you can show, you can record it and shoot it like we can do. Any child can do today, but that time he had to write it with pen and pencil. And after that thing, Dmitry Maryanov said, "It looks to me that Tagore is a poet with the head of a thinker of scientific thinking, and Einstein is a thinker with the head of a poet." At the end of the conversation, Einstein even said to Tagore, "Then I am more religious than you are." Tagore is talking like a scientist, and Einstein is talking like a thinking philosophical person. This integrity is very important for the growth of knowledge in all fields. Of course, ancient India is known for these type of integrated thinking, and I briefly tell you about Aryabhatta, who was in the 5th century, 4th century, 5th century AD. Aryabhatta, and he has written Aryabhatiya, and the mathematical portion contains arithmetic, algebra, plane trigonometry, spherical trigonometry, and extremely accurate approximation of pi. And he has given the radius of planetary orbits in terms of the radius of Earth orbit, and he has correctly stated that orbits of the planets are ellipses rather than perfect circles. And this type of knowledge in that early age is a profound thing, and that's why we have called our India's first satellite. He was given by the name Aryabhatta. And here is the statue of Aryabhatta in the Ayuka, the Inter-University Center for Astronomy for Astrophysics in Pune. And then Varahamihira, he is also in the 5th century AD, and he is a Indian mathematical astronomer, and he is the most noble work is on the Brihas Samhita. He talked about architecture, temples, planetary motions, eclipses, timekeeping, and various other things of this, and on the rainfall, cloud formation, and seasons. Director was telling about the difficulties of giving the atmospheric predictions, and even scientists at that time, thinkers, were worried about this thing. And then he's one of the gems, probably with the King Vikramaditya. And Bhaskaracharya too, who is in the 12th century AD. He's a great teacher, a mathematician, and astronomer, and the 12th century was unparalleled and unsignificant. Many times we know calculus was developed by Newton, etc., etc. But you will be surprised to know that he's considered as a pioneer in the field of calculus. He was knowledgeable about the differential coefficient and differential calculus and the growth, and you will know, even though this has not been advertised. And here is a statue of Bhaskaracharya too in Patna Devi. And therefore, one of our satellites is also named as Bhaskara satellite. And here is his satellite picture that is there. And the tribute given by the Russian stamp in 1984 featuring Bhaskara 1, Bhaskara 2, Aryabhatta greatly emphasized the contributions of the early thinkers and early scientists in this country. And we are taking this tradition. All the youngsters who are thinking should know about this and take it forward further by their contributions in future. Of course, our space is space program has been started by the father of the Indian space program, Dr. Vikram Sarabhai, and he said that the primary task of fundamental research is to discover, and of the research and development is to optimize, and the industry to produce. Therefore, the importance of integrating the fundamental research and R&D for optimization and engineering technology development and industry to production was highlighted by him. And this Vikram Sarabhai's wisdom has inspired the vision of India. Vikram Sarabhai has said, if we are to play a meaningful role nationally and in the Committee of Nations, we must be second to none in the application of advanced technologies to the real problems of man and society. Advanced technology and scientific thing is not for its own thing. We have to solve the problems of man and society, which is also highlighting the theme of the National Science Today, integrated approach in science and technology for sustainable future of the mankind. And the vision of ISRO, Indian Space Research Organization, is to harness space technology for national development while pursuing space research and the planetary exploration. Therefore, contribution to the mankind's progress, the progress for the not only mankind, the progress for the the whole planet. The mankind cannot survive alone. We require all the surroundings, all the life, not only man, but all the biological and agricultural and life is important for our survival together. And all scientific and engineering and industrial contributions have to contribute to this survival. And the director has emphasized on various important aspects in which the institute is contributing, and all the youngsters who are following here should take forward in all these things. And today, the Indian space program is expanding its horizons. We have self-reliance in developing technologies, but the satellites technology, but we have to develop new type of satellites. We have certain type of self-reliance in space transportation, but we have to emphasize in the new directions of the low-cost access to space, interplanetary explorations, human presence in solar system are also important for our growth, and the space applications for societal science, societal services, and that is in the basis and the foundation of all this development. And where are the space applications coming? As highlighted by our director, weather and climate is very important, environmental and ecosystems, education and healthcare, food and water scarcity, skill development, and our promotion of technologies for the skill development, rural development, communication infrastructure, disaster management of various natures, smart governance, sustainable development, and also to some extent we need this space applications for strategic applications, important strategic maneuvers are required, and the space applications will do. In all these things, we need the space program to contribute. And many important things are happening in the space domain, and I have picked up a few flashes that have taken place in the last few years. The Indian scientists have discovered in the first flash year in the June 2018, Indian scientists have discovered a new planet 600 light years away. I will tell you later on what the meaning of the light year. And in the epic Indian discovery, the Physical Research Laboratory has spotted a distant planet 6 times larger than Earth and revolving around a sun-like star about 600 light years away. And in 2019, Nobel Prize in Physics, we talked about Sir C.V. Raman, Nobel Prize in Physics, but the humanities contributions are growing further and further. In the 2019 Nobel Prize in Physics rewards understanding of the universal structure and history. The first discovery in 1995 of a planet orbiting a sun-like star 50 light years away. In 1995, the first thing was found out, and for that thing, a Nobel Prize was given in 2019. And in 2018, a few years later, before this discovery in 1995, our scientists have found out an Earth-like planet about 600 light years away. And earlier we know our sun and a little bit of our planets. But if you see in 2019, the new universe map unearths around 300,000 more galaxies. And that means hundreds of thousands of previously unknown galaxies are listed in the, and this is published in the Journal of Astronomy and Astrophysics. All here you can see all the links for that which we can find out. And therefore, by the exploration of the space is important to understand the life in the, not only on our planet Earth, but the life in other places is important. And to understand this thing, the University of Central Florida developed in 2019, and they have put something called WINE. WINE is not that wine we are talking about. WINE says world is not enough. One world is not enough is a project of, is a part of NASA Small Business Innovation Research Program, and they have found out a steam-powered spacecraft development is put, which can hop between asteroids without running out of fuel, because they mine the water that is available in the targets and use that water for generating the power. It's very important for the future the future explorations of space. And whether humans can go into space, how long they can survive. A recent study in 2019 by NASA shows that long-term space flight travel may not have detrimental effect on human health, and you can possibly survive this type of things in future. That was studied by NASA in what is known as the TWINS study. And NASA patented in 2020, about 2 years ago, an efficient way of trajectory for sending smaller robotic spacecraft to the moon. And this uses the gravity assist of not only Earth and the moon's gravity, and then with that thing you can go to the moon. Small satellites can be sent in efficient way. An opposite problem was done by our team here. In 2006, opposite team I put is how to use the lunar gravity assist to go to geosynchronous geostationary orbits. This was presented in the Journal of Guidance and Control and Dynamics in 2006, and therefore there are a lot of possibilities for scientific inquiry by all the scientists in the world. In 2020 May, Indian Space Research Organization has secured a patent for this method of producing highland lunar soil stimulant for moon soil. These type of studies are important for our future planetary missions. And now we know that a lot of our youngsters have gone into space. Recently, Sirisha Bandala became the third woman of Indian origin to travel to space after Kalpana Chawla and Sunita Williams. They are great inspirations to our youngsters. And Sirisha Bandla has joined Richard Branson's and 4 others in the Virgin Galactic spaceship. And today, now, in November 2021, the NASA SpaceX Crew 3 mission is led by Rajachari. It is going on. It's in space mission now. It is 66 days mission, and the return will be by the end of April 2022. They are in space now, and we are waiting for all the scientific discoveries they have made. And therefore, with this type of background, our space program is working. And recently, few days ago, in 14th February, this month itself, few days ago, we had a PSLV C-52 mission. After a long gap because of the COVID situation, we had to wait, and this was a very successful mission, and precisely it was launched. Earth observation satellite 4 was launched into the prescribed orbit, and this is a radar imaging satellite to provide high quality images and all weather conditions. And along with this thing, more important is the small satellites that have been put. This is the INSPIRE satellite 1 from the Indian Institute of Space Technology, IAST, in association with the Laboratory for Atmospheric Science and Space Physics at University of Colorado. This is a student project, and our youngsters from the IAST, Indian Institute of Space Science and Technology in Trivandrum, has participated in this and developed this. It's really commendable. And we have also launched a joint Indo-Bhutan joint satellite, which is a precursor, and it's the first satellite we have done. And we have total 54 PSLV launches so far, starting from 1993. The first satellite, PSLV D1, first launch of PSLV, Polar Satellite Launch Vehicle, was a failure. And later on, in PSLV 339 in August 2017 was also a failure. We have learned from these failures. Failures were very important to learn And out of 54, we have only 2 failures, that is 96, more than 96% success rate, which is certainly very, very, very good success rate for any launch system. But you cannot expect always successes. Space is never easy. Space program is not easy, and making it routine is harder. In the last few years, I have a lot of many failures were there in the space endeavors of the world, space endeavors of the countries. Phobos grant crashes in 2012. Antares launch fails in 2014. Virgin Galactic Spaceship 2 fails in 2014, and one pilot was also dead. SpaceX Falcon explodes 2016. Long March 4C fails in 2016. ExoMars lander crashed in 2016 again. And PSLV C-39 fails in 2017, even after a great number of 96% success rate. And Vikram lost contact in the moon on our moon mission on September 2019. And more recently, last year, because of cryo upper stage non-ignition, our GSLV F10 Earth observation satellite failed, and therefore failures are there even with the great nations who have done great things in the past. And why these failures come? The launch vehicle travel sequence is a lot of systems are there, multidisciplinary, and the problems can come anywhere. The pre-launch operations and checkout will be taken several days before the launch, and at the liftoff, there will be jet interactions with the tower and wind dispersions, and this can cause great problems to the launch vehicle. And as you are growing, and propulsion, structure, control, array interactions, wind biasing, atmospheric effects, all these things will be together affecting the progress of the satellite, and correcting is important. Any small error in any small these things in these interactions can cause problem. There could be shock oscillations, unsteady loads, base heating, jet interactions, heat shield separation and thermostructure interactions, throat erosions and combustion instabilities can cause havoc to the launch sequence. And therefore, the inertial navigation, closed loop guidance, autopilot, nonlinear sensor dynamics, thrust tail of transients, control interactions govern the correct progress of this thing. And we have to, all of them have to work perfectly. And then we have to separate all these mechanisms once their task is over. And the separation mechanisms, aerodynamic interactions in the atmospheric flight, and falling of those separated things into safe zones is very important. And when you go into the orbit, we have to go into the correct orbit as required by the payload, and mission dispersion should be very small, and we have to manage them. And because of large space debris that is there, the mitigation measures are important. All these things are together have to be done, and this is very, very complex, and any problem can come at any time, and a failure can come. And getting failure with all these system interactions, multidisciplinary interactions, is a task. And therefore, I would say that this is Leo Tolstoy. Have you heard about Leo Tolstoy? He has written very great many books, and he has one of the things is Anna Karenina. And recently, in 1995, there was a very interesting book by Diamond, J.M., Guns, Gems, and Steel, The Fates of Human Societies. And here he has propounded, he was talking about various problems, and he was trying to find out why some animals are domesticatable and some animals are not domesticatable. Differences are there. What makes this thing? And there he has propounded this Anna Karenina principle. This describes systems in which a deficiency in any one of a number of factors dooms them to failure. There are thousands of factors, any one of them can cause failure. In Anna Karenina book, I have read it as a youngster, as a teenager, I have read it. It's very interesting. It starts with a railway accident and it ends with again a train accident. And the first sentence that is there in that book is, happy families are all alike, and every unhappy family is unhappy in its own way. Every failure is because of its own special problem. All happiness is okay, fine. And I put it to the space program. All space successes are same, but every unsuccessful space flight is come because of a very small problem. And therefore, Anna Karenina principle, it has been used for various things. They have used it for management. They have used it for development of scientific science, success in science. For example, in 2012, Anna Karenina principle has been applied to the concept of explanation of success in science. And this was published in Journal of American Society. And space systems must operate reliably under a number of unforgiving conditions. And hence, they present an excellent example of Anna Karenina principle. And we have made a brief paper on this, and this is published in Sarabhai, Journal of Arts and Literature of Indian Institute of Space Science and Technology in 2013. And therefore, how do you find out when so many things are together working, how to make them successful? This is done by thousands and thousands of simulations of pre-simulations of various possibilities, various variations that can be there. The way a launch vehicle can have so many things. There is a guidance model, navigation model, sensor model, propulsion model, autopilot model, control systems are there. The flexibility plays a role, aerodynamics plays a role, and state separations are important. Thermal things are very important. All these things are modeled, and their parameters are not known to us. Their parameters have dispersions, and all the dispersions are simulated in a Monte Carlo simulations of launch vehicle dynamics, and large variations of the input data are found out. And from the outputs, we see if there is any problem, we study that very carefully and try to remove that problem. That's how this the possibility of any failures are there. Therefore, testing and simulations are very, very important in this thing, like in any other scientific domain. And the strides in the computational fluid dynamics and hypersonic testing have gone a long way in understanding many of these things. And therefore, high enthalpy testing methods, because hypersonic, high temperature and hypersonic testing has to be done. And computational things also is very complex, how to design them, how to study them. You can't test everything in possibly in a test facility. Therefore, you must be able to simulate them by modeling also. All these things are done in a very great way. And the Professor Satish Dhawan, who is also the chairman of Indian Space Research Organization, he was also the director of the Indian Institute of Science in Bangalore, and he has done the first supersonic wind tunnel in Institute of Science in 1950s, and similar technologies are developed here. And similarly, the computer models have been developed for various things in the computational fluid dynamics. And today we use the Satish Dhawan supercomputer facility that is there in the Vikram Sarabhai Space Center. And this year we will expand it to 2 petaflops. And we study all the computational simulations, all the testings in the wind tunnel, and see the diversity, see the variations, and simulate the variations in our simulation model, and try to see how to try to test them as far as possible, try to simulate them totally, and from them we reduce the possibility of failures. That's how we get more than 95% success rate in this complex technology. I told you that Professor Satish Dhawan has built the country's first supersonic wind tunnels in Indian Institute of Science in 1950s. But in the world, the first supersonic wind tunnel was done in 1936 in Peenemünde. Peenemünde is in north of Germany, and they have done in the Peenemünde wind tunnels. A memoir was written by Peter Wagner. This is a book, and this is a very interesting book. And I had opportunity to go to and visit this Peenemünde wind tunnels. And they have used these wind tunnels and these studies to develop V2 rocket. V2 rocket is a rocket that is used for destruction, and several thousands of these rockets have been developed, and several thousands were put to destroy many things in the European countries. And therefore, this is when you use this science for destruction rather than construction, and rather than progressive development of the mankind, but the destructive development, then today this is the state of that wind tunnels. This is in ruins. And I had picked up a broken brick from the ruins as a memento, and it is with me. And let us use scientific development for the constructive purposes, for development of humanity, the development of nature, development of ecosystems, rather than for the destruction. That is the message I get. And today, there are a lot of future things are going on in the space transportation. For example, low-cost access to space. Earlier, as I told you, our Sir C.V. Raman, to receive this Nobel Prize, he has booked his ship ticket and several months before the Nobel Prize announcement itself, and he was confident he will get Nobel Prize, and he traveled and traveled months and months to go to one continent to another continent. That was the technology that is there. Today, we have large number of airplanes here. You can travel several hours. Suppose you go to America, you go direct flight may be there and indirect flight may be there. Several tens of several days you may have to spend, and a large number of time you have to spend to go to the other places in the continent. And low cost access to space is a new concept of space transportation, which may be there in the future, in which using the reusable launch vehicle concept and air-breathing propulsions, you can develop low-cost access to space and the future transportation from one point to another point. I'll tell you more about it a little later, because Theodore von Karman, all fluid mechanics and people will know about the Karman vortices, and he described one of the 8 true geniuses in the world. And the von Karman's contributions are very well known in the aerospace area. And he has written in, he died in 1963, but he was few years before his death, he was writing his memoirs in The Wind and Beyond by Theodore von Karman, but it was published in 1967, only few years after his death. And he has described in future, planes may be expected to take off, fly through the air, go into orbit around the Earth, re-enter Earth and choose a place of landing, like that of a conventional plane. This is my portrait of airplane of the future. And now the technologies we are working and little developments are already happening in this direction. And we will, instead of spending hours and hours and days to go to one continent to another continent, today within an hour, because an orbiting satellite takes 90 minutes to go around Earth. One round Earth is 90 minutes. And why are we taking so much of the airplane time to go to Europe, to go to America, etc.? And tomorrow, when this technology is developed, within an hour and a half, you can go to any place in the world. This is the type of new technology that is conceived by von Karman, and he has put it in this quotation. You may be delighted to know von Karman met Mahatma Gandhi ji in 1927. He has written in this book, Wind and Beyond. It is interesting. If you have not read it, read this book. And by that time, from Calcutta to Bombay side to go, Mahatma Gandhi was going by a ship. Several months he has to go. And then Theodore von Karman also was returning from Japan, where he helped them to develop a wind tunnel facility, and he was coming, and he came to know in the same ship Mahatma Gandhi was there, and of course Mahatma Gandhi was there in the bottom of the ship in a in a different kind of in the steerage. He was there in a different kind of this thing. He was in the top class of this thing, and he came to know when Mahatma Gandhi was there. He asked a friend to meet him, and he met Mahatma Gandhi. Gandhi was dressed in a loincloth and was sitting cross-legged on the floor of his spinning wheel. And after his friend has introduced Theodore von Karman to the Gandhiji, we talked of many things, particularly the emergence of New India. India has not become, by the time it took 20 more years for us to get independence, and our conversation was pleasant, but because of the cultural differences, he has not understood completely the contributions of Gandhiji, and therefore he has written, I did not understand the dedication of Indians to this man, because he was not using great technology, a new technology of developing cloth, but he was doing the spinning. The spinning is Gandhiji has used as a tool, as a political tool. And once that is, he has not understood that thing, therefore he has written these things. Okay, we come to our own moon mission. moon mission. We had a successful moon mission, but the first time we have announced this moon mission is in 1999 in the Indian Academy of Sciences meeting, 65th meeting, which happened in Lucknow. And Dr. Kasturi Rangan who was later became the forerunner of this thing. He has beforehand, who has asked us to study on this thing. We have studied, and the first time in October 1999, an open presentation was made on the Indian case for going to the moon. And I had the opportunity at that time also to present about the specific Indian lunar mission. This is my first slide, which I have presented at that time. And my concluding remark says, the Polar Satellite Launch Vehicle offers an excellent route in early Indian lunar orbital mission. The payload capabilities compare very favorably with reference to the recent lunar revival missions like Clementine and Lunar Prospector. And many people have presented there. Narendra Bhandari ji, S. Rangarajan ji, George Joseph ji, P.S. Goyal ji, Sridhar Murthy, they have presented on the various other aspects of this lunar mission. First time we have made in 1999 public announcement. And within few years, in 2008, we have launched PSLV-3. We have said Polar Satellite Launch Vehicle can take it, and C-11 Polar Satellite took off in 2019, and the end of the mission was in 2009, 2018, 2008 we went, and 2009 the end of the mission. And at that time, with the suggestion of the Kalamji, we have also a moon impact probe we have put there, and moon impact probe has come here, and we have developed 32-meter antenna at that time itself. The Chandrayaan mission doesn't require such a big antenna, but we had in mind the Mars mission also in the later, and at Bailalu near Bangalore, this was established and we have used. And this was very successfully done within few years of first announcement of the Chandrayaan mission. And therefore, the International Academy of Astronautics has, and we have taken large number of scientific payloads of other scientists, at least 8 or 9 other scientists are involved from other countries in the world, and their payloads are also have been taken to study this thing. And these are some of the important things that have been done there. And therefore, International Academy of Astronautics in 2013 has given these laurels for team achievements for the international contribution of Chandrayaan-1. I had the opportunity to physically receive this on behalf of all the other scientists. I have received this in the Beijing in China. It was given, and it was a great international contribution under the leadership of the Indian space program. And going to moon is a very complex thing. And if you can see that thing, and the stability and maintenance of 100-kilometer lunar orbit, which we wanted to go in this thing, it varies. In 100-kilometer lunar orbit, our moon orbit 100 kilometers can have a lifetime of a very few days, 16 days lifetime, to 100 years lifetime also, 10 years lifetime also can be there by simply choosing a proper inclination, lunar inclination of the orbit. And this is a very complex situation. How is it an orbit can have 16 days lifetime only? It will fall down slowly, and sometimes it can continue to there for 10 years. And all this is coming because of the gravity field anomalies of that planetary body, lunar small moon that is there. And we found out in our study the 7th and 9th zonal harmonics play a crucial role. And here is the lifetime, and this is the inclination. Some inclinations lifetime is very, very low, like 16 days it can be there. And some inclinations, the lifetime can be very, very high. It can go up to as much as 10 years. And this is the study we have made. And I and my friend, my co-investigator Ramanan, we have published in Journal of Earth System Sciences in 2005. And this is very, very important. Orbit must be maintained by small maneuvers whenever the orbit exceeds the design limits. Our scientists wanted 90 degrees. If 95 degrees inclination is there, you can get large lifetime. But our scientists wanted, for the scientific purpose, 90 degrees in lunar inclination. So finally, we decided to go to 90 degrees, and all orbit maneuvers we have done to keep it in the orbit. And therefore, And I was telling about how to use the gravity assist of the various things. And we go to, and recently a patent was made how to go to moon orbit with the gravity assist of Earth and Moon in a very very optimal way. And here is a reverse problem in which optimal lunar gravity assist trajectories we can find out to go to geosynchronous orbit. We want to go to from Earth geosynchronous orbit. Earth is here and the geosynchronous altitude is here, and we want to place an orbit here. But if the inclinations of the transfer orbit are very high, it will be beneficial to go all the way to moon and then come back and go to GSO. And when the 50-degree inclination in the geotransfer orbit are there for various reasons, then you will gain almost 600 meter per second in the total of around 2300 meter per second by usual approach. This type of possibilities are there in the gravity field, and therefore a lot of opportunities are there in the optimization of these. Even for our moon it is there, and as well other bodies of the planetary things, the March orbiter. This we have published in the Journal of Guidance and Control and Journal of Guidance, Control and Dynamics of American AAA, American Institute of Aeronautics and Astronautics in 2006. And therefore, when we want to go to interplanetary transfer from Earth, we want to go, then there is a Earth sphere of influence is there. It almost up to 1,000 kilometers altitude. It will be there. Here it will be dominant, and then if you want to go to Mars here, it is what is depicted is a Mars transfer. If you want to go around Mars also, there is a sphere of influence. And in between, we are in the influence of sun's gravity. And therefore, there are three phases: geocentric hyperbolic trajectory from Earth parking orbit. And here we have to come here. And then in the heliocentric phase, you have to go here. And not only the sun's gravity, but the gravity field of other planets also will affect this thing. And then when you come near to the Mars, and then you are predominantly in the Mars gravity field, and you have to bring it down. And all these type of things, this type of mission design has to be done. And this mission design has many features. You can use a very simple thing called Hohmann transfer type of things, in which planets are taken as point masses and planet orbits are circular and coplanar. And we can use the Lambert-Koenig method, Patch-Koenig method, pseudo-state method, in which increasing complexity of modeling this thing. And therefore, for example, the advantage of pseudo-state things in the gravity of the planets are accounted by superimposition of heliocentric orbit. We take a heliocentric orbit, and the planetary gravities are superimposed in a certain fashion. That is called the pseudo-state method. And we have published in the non-impact lunar transfer trajectories using pseudo-state technique, again in the Journal of Guidance, Control and Dynamics of AAA in 2005. And finally, when you do all this type of the broad mission design, then accurate numerical method have to be done by search by numerical integration, in which the gravities of sun and the larger planets are considered throughout the flight duration accurately to the great knowledge. And this type of many levels of planetary mission design you have to do. I have already told you about the brief history of the moon mission, and later on Mars orbiter mission also we have done. Our uniqueness of the Mars orbiter mission is that in the first attempt to go to Mars, we have successfully sent. No other country has in the universe has done, and the first successful mission in the first attempt. And there are a lot of technology objectives to develop this technology of this thing. And of course, this is supported by the scientific objectives. Is not for just technology's sake that we are going. Scientists also want to do the exploration of Mars for surface features, morphology, topography, mineralogy, constituents of Mars atmosphere, the dynamics of very upper atmosphere, very low density atmosphere it has got, and emanation of gaseous constituents. All these things are there, and the opportunity to observe Mars moons on the stem. And therefore, we have done the going to Mars in this thing. It takes 26 months. Every 26 months, a opportunity will come, because when you are leaving Earth, Mars has to be around 44 degrees away from this. By the time Mars comes here and you travel here, an arc here to go from Earth to this thing, both of them, when this body, our satellite comes here, Mars also comes here, therefore 44 degrees separation has to be there at the launch from the Earth leaving ellipse to the Mars orbit. And this is called synodic period 26. And every 26 months you have an opportunity, but all these opportunities are not same. If you go in 2013, your velocity requirement is this. If you go in the next opportunity, next 26 months, and then this is the velocity 2.9 kilometers, here only 2.6 kilometers. And therefore, there is all these opportunities are not same because of the inclination of the Mars orbiter and gravity anomalies. Therefore, you have to take the best opportunity that is here. We have suggested the 2013 departing Earth orbit to the, and then going to the 2014 is ideal, and precisely that has been done. Later on you will see, and here we have done using PSLV. Normal PSLV goes like this, but to go for this Mars mission, the entirely different kind of trajectory with a large coasting time between the third stage and fourth stage to do the required augment of perigee. And so many things are possible here, so many trajectories are possible. We have done with the best type of solution that is there, which is optimal with the PSLV itself, the Polar Satellite Launch Vehicle, which is a small, our thing with the thing we have started as planned on 5th November 2013 is the launch, and the departure from the various Earth orbits slowly, gradually we have increased. We had a little problem in the post-burn of the 6th, therefore we have to do two things here and corrected it. And then finally, we left on 1st December 2013 as planned here. 1st December. The exact date is 30 November, and then we have opportunity of that thing we have done, and it is reached precisely as planned. And insertion was done on, Mars insertion was done on 24th September. Excellent thing. And then how we have planned here? When we have planned here, pre-launch planning is AN75, all these Earth-burn operations, total is A75 meter per second has to be given. And finally, what was given is very close to that A73.4 meter per second by actually planning here. And this is the pre-launch planning, but as you are launching, we get the information of where it is and then recalculate the burns, and we do, and the closeness of the planned and obtained things show this thing. And when we reach the Mars orbit, this is towards Earth, this is Mars, this is towards Earth, and Earth is from Earth we can see like this, but the insertion was done on the opposite side of Mars, and therefore the insertion operations into Mars orbit cannot be seen from Earth. Everything has to be seen, it is in the shadow, and we have planned this thing shadow. That means everything has to be done on board, and we cannot do it from the Earth. This was correctly done, and the communication blackout, in the communication blackout we have done it, and resuming communication after the orbit is achieved. And while we are seeing the Mars orbiter mission, it also later on it's looked at the various satellites of the, there are two satellites, Phobos and Deimos, and we have seen from our orbit the Deimos satellite here. When we are reaching the Mars at that time, unfortunately we can say a comet has going very close to Mars. And the comet Siding Spring has the closest approach on Mars in October 19th, and with a great speed zipping past at 56 kilometers per second. And this was not known before because it was coming from far off places. And then we have to be careful, and we have to see that the emanations from this comet's tail do not impinge on our Mars orbiter mission payloads and spoil them. And we have done carefully all this analysis and then seen that nothing happens there. And therefore, this was very successfully done. National was very happy. And then on September 2015 issue of Current Science of the Science Academy, We have devoted it to Mars orbiter mission and everything that has to be done with the forward of Kiran Kumar sir, who was the chairman at that time, and the conceptual design is my thing, and all other things are there. All these things for the posterity is published. Earlier, people were thinking that going out into space is not possible. That was in the early part of 19th century and 20th century. Also, people were thinking going to the moon is going to the moon, going out of Earth's orbit, out into Earth orbit itself is not possible. And only a century and century and a half ago, people were thinking like that. And here, therefore, we should, it is be easier to see into the thing. And it was Hermann Oberth who has studied this thing and then he found out it was possible to do that. Therefore, in 1922, as a very young man in the he was in his 20s. He was born in 94 and 22. He's around 27, 28 years. He has written a dissertation, doctoral dissertation on rocket science. That we can go, how to go to orbit and Earth orbit, to the rockets, the planetary space. For rocket into planetary space, this was rejected by the European university to which he has submitted, saying that is utopian. You cannot go. Into this is all a utopian thing. It is not correct. And within less than a decade, Oberth has conducted a static firing of the first liquid fuel rocket motion. He was helped by an 18-year-old student, Werner von Braun. Later, von Braun, you might have heard, he has done great things, and he went to USA, and he was instrumental in doing many of these moon missions, etc., etc. At 18 years, his assistant, he has shown that we can have the rockets to do this thing, and people were thinking that it was not possible, and therefore, and of course, I had the great benefit of meeting Hermann Oberth in person when he was 92 years old. In 1987, I met him, and on this met him in Europe, for which I went for a conference, and he was also there as a he just came and he was sitting here, and I took his signature here. Within 2 years, 1987, in 1989, he passed away at the age of 94. And it was Oberth who found out, and we call it as Oberth effect, that interplanetary space flight is possible. And he came to this idea because his interest in, I said, where do you come from? You come from your childhood. Oberth's interest in rocketry was sparked at the age of 11. His mother gave him a book, Jules Verne's From Earth to the Moon. Have you read this book? We all read this book when we were small. It's in Jules Verne. It is a science fiction thing, but he has written, and Oberth has read this at least 4 to 5 times, 5 to 6 times, and he knew it by heart. And later, as a young man, he found out Jules Verne's creativity is not simply fiction. It is very, very much possible to do this thing, and there is some type of unknown scientific basis to this. He has found out, and that is called Oberth effect. In scientific literature now here, it's called Oberth effect, and he has found it out. In interplanetary spaceflight, Oberth effect is used in Oberth maneuver, where the application of an impulse from a rocket engine close to gravitational body, where the speed is highest. In the gravitational body, when you are going, when you are near, the speed is higher. When you are far off, the speed is less. That is the scenario. And when it is high, if you give the additional velocities when it is high, then you will get much more effect. This is the concept of the kinetic energy. We can explain here. This is the Earth here, and the Earth's escape velocity is 11.2 kilometer per second at certain low altitude. That means less than 11.2 kilometer per second is there, it will be in the Earth orbit only. But if you give more than 11.2 kilometers, then it will go out of Earth orbit, and in the parabolic part, it will start going fast. And when it goes very far, the relative velocity with respect to Earth will be, the velocity will be 0. It will be, here it is 11.2, it is 0. Oberth has found, if you add some more velocity here, instead of 11.2, I suppose I give 11.6. That means 0.4 kilometers second. That means 400 meter per second I have given here. When it goes here, it will not be 0. It will be more than 0. Here we have given 400 meter per second. When you come here, it will not be 400 meter per second additional. It will be it will be 3 kilometer per second. Here it is, I have given only 0.4 kilometer per second more velocity, but by the time it goes, the V infinity is 3 kilometer per second. This is called the Oberth effect, very simple effect of kinetic energy, and the incremental kinetic energy is given when the kinetic energy is high. And that is the principle here, and this is called the Oberth effect. And because of this, we are able to go into this thing. It was not found out earlier, and people were saying, when he wanted to publish it, he said PhD will not be given to you, refused, and he published it himself with his own money. Therefore, with this type of great contributions of thinking people, thinking beyond the known knowledge and to the new knowledge, the possibility of solar system exploration is made possible, and we have achieved our first mission of the moon. Of course, we had some problem in the landing in the recent mission of the moon, and first time attempt to Mars we have successful, and we have possibilities of going into other solar system exploration we have developed here. And recently we had a workshop at Physical Research Laboratory, and there we have published, there we have presented this thing and great thing, and there are great scientific objectives. The exploration is driven not by just by technology. Science meets the scientific objectives, and the objectives are origin and evolution of planets, atmospheric composition, internal structure, resource utilization that is there in these things, and the possibility of life in other planets are also is possibility of science thing. These type of things are there, and we use our launch systems there. So far we have used PSLV. I call it as PSLV-G because using this workhorse PSLV, we have successfully got Mars orbiter mission and Chandrayaan mission, and now we have other bigger satellites that are bigger launch vehicles that are required. GSLV Mark II is there, GSLV Mark III is there, GTO capability of almost 5 tons just in transfer orbit capabilities, and the future Mark IIIs are there with increased capabilities, and heavy lift vehicle with much more GTO capability we are developing. All these things will be used in our future missions. And in the Mars, people have gone, and the Mars still continues to interest the scientists because all the Mars things, these are Mars crustal dichotomy is there. All the Mars things in the northern hemisphere of the Mars, not on the southern. That is because of the low depth. These are the low depth things are these. Mars topography is very complex, and this is very low and this is very high, and the high domains we have not come because we need the time that is required to reduce the velocity from orbital to the landing thing, and therefore most of the things are in this domain. To go to this thing, you have to have appropriate breaking of the velocity that is there, and the entry, descent, and landing technology development you have to use, and technology that can be used, maybe these type of decelerators you have to develop, and these decelerators can be used to reduce this thing velocity, so for the safe landing. Or you can use also the possibility of supersonic retropropulsion, inflatable decelerators. These type of technologies are required to go into other areas of Mars which are still awaiting in situ analysis. And then parachutes and supersonic planetary entry can be possibly used, but in supersonic re-entry, there are what are known as area oscillations, and this is Anita Sengupta. She has visited our Indian Space Research Organization, Bangalore, also gave a talk. And the fluid structure interaction of the parachutes and supersonic planetary entry, these are area. and these oscillations have to be handled, and the turbulent wake coupling will be there. These have to be handled. You also can use supersonic retropropulsion. It has advantages and disadvantages, and that also can be used to reduce the velocity for safe landing onto the Mars. And also we can use what is known as the weak stability boundary transfers to Mars. This is a recent study that is done and published in 2019 in the Journal of Spacecraft and Rockets by our team. Madam, our young scientist Pooja Dutt has done her PhD under this thing, and this is a joint paper that has put on how you can go to weak stability boundary. When the planet sinks on the weak stability boundary is the area in which the planetary gravity balances. When you are in that, from that area, you can use the diversity there to go optimally into various places. This is the how to use the weak stability boundary transfers to Mars has been the study of Pooja Dutt's PhD work, which was published recently. Various types of things are there. We have also published the possibility in the future of how you can use for a expedition, human expedition to Mars. Human expedition to Mars, establishment of a human settlement. This was the theme of the Journal of Cosmology in 2010. And we have, from our side, Indian Space Research Organization, myself, Priyanka Bandapajay, and Madhav Nair sir, who was at the time the who was there leading this thing. And we have seen how by a series of launches from Earth, not one, but about 5 launches of a expanded version of a launch thing, we can have a payload, and we can consider a habitat module in the surface of the Mars, and then later on you can have a habitat module which will be landed on the Mars, and then it will be there to receive the astronauts. And then we also have a transit habitat module in the orbit. A big thing is joined here and kept ready, and for that you have to have around 4 launches, and then the final launch will be with around 6 people, and they will come here and they will go into this thing, and they will join here. And then already established system, you have habitat module, they will live here, and we'll come back again to Earth after this thing. This type of concept has been done and published in the Journal of Cosmology, the possibilities of expedition to Mars, establishment of a human settlement. These are type of thing that can be there in the near future. This is planned for 2035, but if it is not possible, it may be helpful. Mars is over, and then see Venus is a very important thing. Many times Venus is known as Earth's sister planet. Venus and Earth are of the same size. I have put here in the scale here. The unit here is 100 kilometer, 1000 kilometers this, and Venus, this thing is almost similar size. Earth is 127.56 kilometer. This is 127.56. This is 121, almost same size. And Earth Venus size are very thing. And Venus is around 81% of Earth's mass, the closest planets to Earth also. But this is where the comparison ends. One day in Venus is longer than 1 year, because due to the slow rotation of its axis, it takes 243 Earth days to complete one rotation, whereas the orbit around Sun, it takes only 225 Earth orbits. Therefore, its day is longer than its moon of its year. And also, there are winds in the Venus atmosphere, very complex winds, and at certain altitudes, around 60 kilometers altitude, around 100 meter per second. From 100 meter per second, and winds are there, and it comes to 0 at the surface, almost 0 at the surface. And because of this type of things, there are the giant vortices, and the polar vortices are there. Super rotation causes giant polar vortices, very complex atmosphere there, and wind speeds are 60 times faster than the rotation of the planet itself. That type of winds are there, and therefore, with this type of this thing, how can you have a human exploration to Venus? You may think the Venus surface is hellish, but at 92, it is 92 atmospheres of pressure. When you go there, you'll be crushed. Whereas temperatures are almost 500 degrees centigrade, you'll burn out. But the surface of Venus is not for humans. But you forget about surface. At 50 kilometers above the surface, Venus offers almost atmospheric pressure. type of thing, only slightly lower gravity than this. Gravity also similar, and yes, and then also the rotation speed also around this thing. It will not be 230 days or something. In 4 days it will rotate, and therefore at an altitude, if you have thing, it will be thing. And Venus missions can happen every 8 years. Good opportunities will come. You can see the cyclic opportunities we have worked out. 2018 to 2050, what are all the possibility thing. And in 2013 it comes 2023, 2031, 2013 are the possibilities for us to go to Mars. And we have studied with our GSLV Mark III what type of science payload we can take, and we can get almost 500 into 5,000 kilometers orbit around Venus with 178 kilograms of science payload can take there. And then these type of possibilities are there, and these detailed mission studies have been done. But if you go in future to higher altitude and keep your thing, don't go to the hellish scenario at the surface, but you go into 100 kilometers or 80 kilometers away from the surface, then you can have a colony there. And therefore, this high altitude Venus operational concept HAVOC is being studied by NASA, and there are 5 phases of this thing, and the debate is continuing. Will human build colonies or float over Venus is not known. And there is this book by Robert Walker highlighting about the disadvantages of lunar colonies, advantages of cloud colonies, and it may be possible in future there will be colonies established by humans around Venus also. Similarly, planet Mercury study, we have studied how you to go to planet Mercury. Planet Mercury is very near to Sun and closer to Sun by 6 times as intense solar wind compared to Moon Earth system. And therefore, we have to be careful. And because of the gravity also, the going orbit around Mercury is very difficult with our technology that is there, with our capability of launch systems. But there is a great scientific interest in the studying the Mercury. Therefore, we have found out we can have a resonant orbit about Mercury. That means our spacecraft orbits Sun once in every two orbits of Mercury, and therefore every 2 orbits of Mercury you will reach our spacecraft, and the Mercury will be nearby, and with that thing you can do this type of thing. Earth to Mercury transfer, 2:1 resonant orbit you can do. And we use here the gravity assist of Venus, Mercury, and Mercury 3 times gravity assist of Mercury, 1 time Mercury of Venus. And also we use some departure space maneuvers in the space. With that thing we can have with our system, existing launch systems, this thing. And therefore, and we are also thinking of lunar sample return mission. Our landing mission was in a problem. We'll solve it later in this year itself. There will be Chandrayaan 3 will be there. And then how to get a sample return for this thing. Our scientists said that currently all the samples are near the Apollo in this triangle, and there are various other places where the samples are not there, and particularly in the Lowell crater and SPAB. SPAB is the Schrodinger basin, the South Pole Aitken basin. It is there. There is a Schrodinger basin. From these places, if you can get the samples, it will be very interesting for the scientists to understand. Recent volcanism at this Lowell crater will be very interesting for the scientists to study, and unique opportunity to investigate the advent of surface maturation process. And therefore, we have found out later on, this also has been studied. And then this is to the Jupiter. Here also we use gravity assist of Venus, Earth, Mars, Earth, Venus, Earth, Mars, Earth, and arrival to Jupiter. Here also we're using the heavy lift vehicle, almost orbital mass of almost 2 tons. Orbital mass can be there. And then our scientists feel the study of some of these moons of Saturn are very important. For example, Titan is very important because Titan's atmosphere is made of the same constituent as Earth, nitrogen, And Titan is only the object under the Earth where clear evidence of stable bodies of surface liquid have been found. And therefore, scientists want to study this thing. A lot of scientific objectives are there. Therefore, we have studied the possibilities of going to Titan. And Europa is a satellite of Jupiter, one of the 4 satellites of the Jupiter. And Europa is the most intriguing object in our solar system. And it offers the key to understanding the habitability of icy worlds. This stems from the possibility that Europa has a global scale ocean buried beneath this icy surface. And there may be possibility of life in that. And our scientists want to study this thing. And therefore, we have a possibility of having an orbit 500 kilometers to 1900,000 kilometers around Jupiter. And from there, we can study all these Europas, etc., etc. And you may be remembering that Galileo has studied this. And many of the asteroids are very important because of various reasons. The lot of asteroids, positive reasons of having the various minerals that are there that can be useful to us. Negative reasons to understand asteroids, they can cause havoc to Earth and life in various ways. And therefore, we have studied here Earth to asteroid series transfer with double Mars gravity assist with heavy lift vehicle. A mass of around 1 ton kilograms can be achieved. And our scientists want asteroid sample return mission, and they found out this Hysia, which is the carbonaceous C type of asteroid, the carbonaceous type of asteroid, and the largest carbonaceous, 4th largest asteroid, around 440 kilometers in diameter. And this was discussed way back in 1849, and various scientific objectives are there, and the possibility of return mission. We launch from here, we go there, and then take a small piece of that thing and come back in 1957. 2057 is 100 years of 1957 when the first mission space mission was done by Russians. Therefore, asteroid sample return mission was also found out. And therefore, these are all the possibilities. I have quickly gone through the possibilities of Mars orbiter mission, mission to Venus. Of course, the Alpha point I have not highlighted, but the mission is going to come. Resonant mission to Mercury, 2:1 resonant mission, lander mission to Mars, lunar sample return missions, mission to Saturn, Jupiter with gravity assist, asteroid rendezvous, and possible mission of a sample return mission from Hysia. Possibly we launch in 2052 for this thing, and in the 5 years it will go to Hysia, and then study that, take a small piece of this thing for study, and come back to Earth in 2015, which is the 100 years of the space mission that has happened by humans. This is the type of possibilities. How much of this will be actually done will depend on the future explorations. All the youngsters who are here, what are the lot of developments are required, and based on this, the question mark will be removed, and new kind of things will be there. And therefore, why are we going? And why humans want to go to the outside this thing? It is important for the human race to spread into the space for the survival of the species. Life on Earth is at ever-increasing risk of being wiped out by disaster, such as an asteroid collision. I'll tell you more about it. Sudden global warming, nuclear war, a genetically engineered virus. Oh, we are facing problems with viruses. Other dangers I've not yet thought of. But once we spread into space and established independent colonies, our future should be safe. This is what Stephen Hawking, he came to India, and also Stephen Hawking is a great thinker, and he has said that thing. And these are the similar strategies proposed by US space exploration policy also says. The goal is not just scientific exploration. It's also about extending the range of human habitat from Earth into the solar system as we go forward in time. For humans to survive for hundreds of thousands, millions of years, we must ultimately populate other planets. Other planets in coexistence with the life there, not by killing. Please remember. But when you go to the human space missions, there are a lot of hazards, radiation hazards, which are technological, which can damage the onboard systems, which are biological, which can be, humans are susceptible to biological effects of this thing. And therefore, when you go and stay, the electrostatic shielding concepts for protection from the charged particles, etc., may be required to be developed. And there are a lot of microbes ever living here. There are more microbes, several times, several hundreds and thousands of times more than human beings. They inherit the world, I think. And the microbial risks in space are more for us, particularly when you travel in closed spaces like this. And the microbes survive much better in the free gravity entity of the space. This is the rate of microbial development, microbial generation. They grow faster than in Earth, than on Earth. This is the study that is made by the Russian studies that are there. Microbes survive better, and humans have problem. Therefore, in the frontiers of microbiology, and recently some things are happening. This is in 2019 February. It was put herpes virus is reactivated on humans when you go there. And the lead author is Satish K. Mehta from Johnson Space Center. Obviously, he's an Indian origin. And to date, around 47 out of 85, that is more than 50% astronaut in short space shuttles, and 61% in ISS missions shed herpes virus in their saliva and urine samples. And therefore, researchers are continuing for looking methods for combating reactivation of the virus, which will also benefit those on Earth. And therefore, what we are studying for the survival in space also will help for survival on planet Earth itself. And there are a lot of other problems also. There are a lot of terrestrial impact craters. Here this is the planet Earth in this plane we have given here, and there are in the past great impact craters are there. There is one here in this thing, a lunar crater. I'll tell you about this, and I'll tell about this crater and about this crater a little more clearly. And this is the lunar crater on Earth, which is here, and this is lunar crater is there around very near to the Bombay, around 550 kilometers from Mumbai, in the Buldana district of Maharashtra. And this is the current thing. The lunar crater is the world's largest basaltic rock crater. It is 1.83 kilometers in diameter, 170 meters in depth, and the estimated age is around 52,000 years, around 60,000 years. It was done here, and recently in 2011, a particular bacteria was found and isolated here, which was nowhere available in lunar crater, and this was named as Indbacter alcaphilus because it was found in India, and it's also in mythology, Lavanasar. Also, this there are things. The impact origin of the crater is now clearly demonstrated by the shock metamorphism caused by the hypervelocity impact that has transformed a plesiogenic feldspar into mescalinite. Therefore, from the rock shattering mechanism, they found this certainly from impact from this thing. Many times other impacts also can happen. Our own orbits, our own man-made objects can come and impact, and they may cause small problems, but there are so many things that are there. Recently in Dindigul also, most probably the Vega upper stage module, and so many things have come. The humans dying because of this is very, very rare, and it has probably not happened, or maybe happened once or twice, and this is a small thing. But a big asteroid coming and hitting can be disastrous. And recently in Science magazine in 2010, more than 45 scientists across the world has published this thing, the Chicxulub asteroid impact of mass extinction in Karena's paleogenic boundary. It has happened 65 million years ago, and this was studied by Nobel laureate Luis Alvarez and his geologist son Walter Alvarez. They have studied this, and they hypothesized 1980 that possibly 65 million years ago a big asteroid has come, and this might happen. They have studied this. They have found it from the iridium samples that were dug all throughout the Earth in various places, iridium samples, but they were very, very, very high. Iridium samples are not there naturally on Earth, but they were very, very, very high. To when they deep, they can find out the years, around 65 million years ago, depth, the iridium samples are there throughout the world, which is not natural to our world. Therefore, they found an asteroid where iridium samples are there, might have hit, and then it may have covered the whole Earth 65 million years ago. But then if it hits, then there is a big crater has to be there, and there was no crater of that size. Almost 200 kilometers crater should be there on Earth, should be created. And 1980, it was not known. But young graduate student of University of Arizona in 1990, by analyzing the photographs that are taken from satellites, he has found out possibly at this place, at this crater, Chicxulub, at this crater, at this point, this is South India, this is South America, this is North America. Here, the crater must be there. Later on, actually, it was found 65 million years ago. There was there. Second before impact, a big material has come. 1 minute later, it has blasted like this, and then 4 months, the whole dust that is covered from this asteroid has covered the whole Earth. And then 1,000 years later, a big crater is a double crater you have seen. You will see scientists have worked out and found that a big impact will cause double crater like this. I'll show you. And then this is in Gulf of Mexico. It must be there, and it was found out. And this is a study hypervelocity impact process, and the scientists have studied a big impact, asteroid impact is there on surface, and the whole thing will come up like this, and the impact is very, very high impact is there. Instead of a single crater, it will come up again, a double crater will be there. The Chicxulub crater was like that. And many times, this was 65 million years ago, very rare, you may think. In Tunguska is one thing that has happened only in 1908. The asteroid is believed to be around 60 meters across, caused air blast in central Siberia in 1908. And nobody knew about it. And around at that time, because it was around 2,200 square kilometers of area, around 60 million trees were felled here. And today it is a place like this earlier. And this was all done. And they were at that time, because of the light that was generated there, and the sky was brightened by 48 hours. And in London in the night, midnight, people, you could walk and read newspapers because of this light. But they were not knowing about this. Much later only it was found out it was because of this crater. Therefore, we have to defend our planet Earth. Planetary defense is very important. There is a planetary defense conference that happens every 2-3 years. ISRO is a party to that, and we have 2021 Planetary Defense Conference in Vienna. This is in the virtual mode because of the recent things, and therefore we can, with the current technology, we can find out a big asteroid is coming, and if it is coming and it is a possibility of impact here, there are technologies possible to deflect it slightly so that the disaster can be avoided. And therefore, and this interagency state debris coordination, it was told that we were closely involved in that thing. It tells about how human-made debris can be controlled, and how to remove this thing. All these things are possible, and how to do it. And we do this type of proximity analysis, space debris proximity analysis. It can be dangerous to our own launches. For whenever we are having a launch, we will see whether it is likely to interact with any of these bodies, any of this existing debris, man-made debris particularly. They are all coordinated, and we tell with our analysis, don't launch at this particular time. If you have to launch here, please postpone it. And this is the type of thing what the Chandrayaan mission we have done. Similarly, all other missions, every launch that takes place from this place, Sriharikota, we do this analysis and clear it from the space degree point of view. But now, you may be knowing, this is the news flash here. We are talking about planet Earth, but now possibly the Chinese Long March rocket that was launched in October 2014 is about to hit moon on March 4th. March 4th is only a few days from now. On the other side, our team also has generated this thing. Of course, there were debates whether it is whether this orbit that is coming is this particular Chang'e, but some scientists said this, some scientists say it's some other thing. But certainly it is going to hit moon. Please watch your newspapers, etc. March 4th, on the other side, on the visible side is there for moon, on the invisible side is back side is there, invisible side. It is going to hit on the other side, and it is not a big crater that will come. The crater will be around 20 meters only. It is not a big this thing. And these type of things are happening to the Earth. We have shown, and now it is we see that it can happen to the moon also, and therefore we have to control this thing. If you uncontrolled, the debris will go on increasing by this our air activity, by its own internal heating. We need not have to do anything. By itself, it will grow. And to control this thing, we may have to do active space debris removal. By not many things have to be removed. 1 or 2 or 3 big possible things can be removed, and then it can be controlled. And so we have already initiated action to access systematically, systematically do the active debris removal. And there are many possibilities for asteroid deflection, asteroid tug blow, gravity tractor, solar contractor, solar sail, and impact it and throw it away and use it nuclear explosion before coming, or you use what is known as the Arkowski effect, is a thermal effect. One side of this is heated, other side is not cold, and that will generate a force. All these deflection methods can be used for asteroid that is going to come to slightly deflect it and throw away. And that's how we can save humanity. In the future, the thinkers are saying that we may go to, humans may go to space, but you will be surprised to know the space is not nearby space. In much later, we may go to far off space. This is the journal. This is in British Interplanetary Society Journal in volume 70 in 2017 and in volume 21 in 2018. This type of study was prepared, in which a ship of this time will go, and it will go to the nearby another planet, into the nearby galaxy, the nearby star, and therefore the time taken, the group is to reach that star in the Proxima Centauri, near our nearest star group. There are three C stars are there together, and if you go to Proxima Centauri B, it will take, the time itself will take 6,300 years trip with the current technology. Even if you go very close to the speeds of light, it will take this much time, 6,300 years things. And that means a person who goes will not reach there in his lifetime. Not only his lifetime, many generations have to do. Therefore, this is called a generation ship, multi-generation space journey. These are the type of possibilities that are there. And therefore, when you are going multi-generational, you have to take a big team which has health experts, which has agricultural experts, which has literary experts together. Therefore, they can grow there as a colony. And these are the type of possibilities that are there in the future. And these are the type of papers that have come in the British Interplanetary Society. What actually happened will be for the future generations to do. Before we are coming to the end of our presentation, and here Arthur C. Clarke, Sir Arthur C. Clarke is the one. He is a great. He is a person. The Clarke orbit is our geosynchronous, our GTO and synchronous orbit to Earth, from which we can the space platform can be used to study. This is the one that is proposed by him initially. That's why we call it Clarke orbit. And then he has proposed 3 laws of prediction. The first law was done in the 1962. Then in 1973, he has second and third law he has put. And then 3 laws are good enough for Newton. He said, I'll stop. But in 1999, he said, I need a 4th law. What is the first law? When a distinguished scientist, elderly scientist like me, says something is possible, he is almost certainly right. But when he says something is impossible, he is probably wrong. Because the new generation, what we think as impossible, the new generation of youngsters who are watching this and their youngsters will make it possible. The only way of discovering the limits of possible is to venture little past into them impossible. By studying the impossibility, you make the impossible as possible. Any sufficiently advanced technology is indistinguishable from magic. I know it very well. When I was a young person, when I was a child, what are things that are there today are not at all imagined by the brightest of the minds. What is today is like magic at that time. Later, in 1993, almost after 25 years, Clark has enunciated the fourth law. And that is very important law for scientific exploration. For every expert, there is an equal and opposite expert. This is almost like Newton's law. For every force, there is an equal and opposite force. And that is the one that governs many of these laws. But for every expert, there is an equal and opposite expert. One expert says this, other expert says opposite. We cannot say who is right, who is wrong. Both are important. Both have to study. Both things have to be studied. The truth will be found by understanding, by studying more and more. And therefore, this is not a conflict for killing each other. This is a synthesis to learn more and more. Therefore, these are very important. This is the youngsters that will take us into the new field. And I see the youngsters are doing great work. Youngsters from India who are all there now watching here also are doing work. For example, NASA every year, it does, every 2 years, it does this space settlement contest. Ames Research Center with the National Space Society of the USA, they do the space settlement design contest annually from 1994. And all students up to 12th grade from all over the world can participate. And I have seen our youngsters from India have done very, very well. And I have picked up randomly some of these things. For example, from Odisha also, these are things. Odishan design inspired systems for aero vehicles. This was done. And this is Pooja Bhattacharya and Swastika Bhattacharya in 2009. She's from, they have done Odishan design inspired systems for aero vehicles. I was fascinated so much. We have invited them to Vikram Sarabhai Space Center, and they have visited this place also. Like there's so many of them from across the country, large number of people, youngsters who are in the school are participating and telling space settlement context ideas they are giving. And for example, specialty first prize for artistic merit, Mrinal Chaudhary from Odisha got in 2011. Like that, so many. I hope the youngsters who are now watching this thing have ideas here to participate and take the humanity further into the future by having these type of ideas. Already things are happening, youngsters are doing. For example, this little youngster whose name was Nandini Sharma in the year 2000, in the year 2007 in the Intel International Science Engineering Fair, she got first place for her work in the microbiology project. This is a project that is here, and she has described it. Well, like today, we have research scholars are doing so many fantastic things. I told you, I have gone through these things, and they are very interesting things are there. And for her first prize, she got first prize at that thing in 2000 an Intel thing. And later, when asteroid 2000 WQ57 was found in 2000, and there is a naming system for the asteroid, and this asteroid was renamed as Nandini Sharma. There is an asteroid by the name Nandini Sharma, 23228 Nandini Sharma, an asteroid is there. I hope many of the youngsters will do excellent work, and many of the asteroids named after them in future. And recently, a few months ago, every October we do the World Space Week. And there is history for October World Space Week. We are part of that history anyway. And we have conducted here in Kerala, a Space Habitat Challenge conflict challenge competition. And as many as more than 250 teams have participated. And this is the first prize, second prize, third prize in the senior category in the colleges. And this is first prize, second prize, third prize in the junior category in the colleges. And it is very nice to see youngsters participating, thinking about the Space Habitat Challenge and thinking about the future. The future is in your hands, not in the hands of all the people who are this thing. And therefore, it is like your type of inspiration is described by Jonathan Livingston Seagull, and is written by Richard Bach. This book, this is about a seagull. This is the fable on self-perfection. It's first published in 1972 by 70 and 972 million copies or so. This is a story of people who follow their hearts and make their own rules of achieving excellence. We have to struggle, and then only. It is not for like other seagulls who want to eat breakfast and how to get breakfast, how fast I can go, how I can go, how to go. And this is, they get special pleasure out of doing something well. even if it only for themselves. People who know there is more to this living than meets the eye, they will be right there flying higher, faster than ever dreamt. And this is a beautiful book. I was inspired by this book also. We read it in when I joined here. This book is there, Jonathan Livingston. Seagull, this is about seagull, but it is special seagulls who work for perfection. And what I learned as a scientist here, I'm a scientist, space scientist and space engineer, but I have found when working here, the extent of the world. The world is very, 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 very big. We are talking about our Earth and we are fighting and killing, but the vastness of this thing is what I understood here. For this vastness, what you have to do is the speed of light. You know that light, the fundamental light goes and then in 1 second, it goes 7.5 times Earth circumference distance. In 1 second, if it goes around Earth, it doesn't go, of course, it stretches, it goes 7.5 years. Earth to Moon, it takes a little more than 1 second. Sun to Earth is 8.3 minutes. Sun to the closest star, Proxima Centauri, this thing, around 4.24 years. Across the Milky Way is 100,000 years. Our own galaxy's closest spiral galaxy, Andromeda, the closest spiral galaxy is 2.5 million years. And the limit of observable universe to Earth today is 13 billion years. Can you understand? Around Earth, 7.5 times it goes in 1 second. And to go observable universe to Earth is 13.8 billions. It is huge, huge, unimaginably big, infinity. And this concept of infinity is speculated by our own thinkers. In Ishavasha Upanishads, when I was a young child, I read this thing. Purnamadaha Purnamidam Purnat Purnamadachyate Purnasya Purnamadaya Purnamavashishyate. When you, that is whole, this is whole. When you take the whole out of the whole still remains whole. That is the concept of infinity. That is there. The whole universe is infinite. And people did not know about it until recently. In 1584, when Leonardo Bruno proposed an unbounded universe and other suns that are there existable, when he proposed this thing, it was thought as heresy, and Bruno was burnt at the stake. He was burnt alive at the stake for his ideas that the universe is infinite. But other solar systems exist. Even few centuries ago, humanity did not know. Of course, some thinkers, as I told you in the beginning, a few more centuries before, understood that possibility of this thing here. But the life is vast, the universe is big, and we have to perceive this. It is youngsters who will take there. Of course, great people like Vikram Sarabhai, Sir C.V. Raman, Satish Dhawan, they guide us to and inspire us to take us further. Lives of great men all remind us we can make our life sublime, undeparting, leave behind us footprints on the sands of time. But it's the youngsters who are watching here who will take us into the future. And I'm very happy to be with you all today in this very important day, National Science Day and the Research Scholars Day, and particularly, possibly, large number of young school students are also participating. The universe is yours, the future is yours, and we watch you to understand this thing, watch you to achieve the unachievable. Thank you very much for the time you have spent. My talk is over. Can we close this thing, gentlemen?
Thank you, sir, for this excellent presentation from the history to the latest updates. I think all the audience must have enjoyed it and must have something to take home today. So, sir, I will request our research scholars, they may have some questions they will ask you. So, students, if you have questions, you may ask.
Certainly. It will be a pleasure to interact with you. If any specific question is there, and it is in the area of my knowledge, certainly I'll say. If it is not in the area of my knowledge, certainly, gladly I'll say that also. Okay, go ahead, please.
Yeah, students.
Very well formed lecture, sir. My question is that
You first identify yourself by your name.
Yeah, I am Satya. I am a research scholar here from the School of Electrical Science.
Very good,
So
Satya.
my question is, you have gone through the history of missions of the space. So my question is that as a course of the missions, you will have a lot of space debris, I can say,
Yes.
which can be collected, which may not be collected. But if the collected thing, is there any practices of using it in a sustainable way, either at ISRO or IAST or research in that directions? Can you give some light?
Yes, I have in some of my slides highlighted the importance. The space debris is all objects 10 centimeters and above are closely monitored by the space observational systems. They are recorded and we know their progress and their trajectories are there. In the Indian Space Research Organization also, a independent center of the Space Situational Institute is there now, established in Bangalore, and they do a lot of studies here. Vikram Sarabhai Space Center initially started this thing. There is a big team studying this space debris effect. And we have, for example, we said March 4th, this debris generated by here will hit moon. And that also has been studied at length, in addition to many scientists in the world. Here also it has been studied. And more important are the space debris, things which are not observable. Millimeters size, less than 10 centimeters are there. It is very difficult. It is not possible with today's technology to observe from the Earth and catalog them. We may observe them from the satellites itself. Therefore, some of the satellites carry instruments and other systems in which you can observe them and catalog them. And even small of them, even a very small particle of few millimeters, because of the relative velocity is very high, can cause disaster to this thing, and therefore this is very important. And it was found by some method, these debris, big part of the big debris which collide with each other will become small debris and cause more havoc. And therefore, some of the big portions which can cause big objects in space, man-made objects, which can cause these things, if they are removed systematically, then can be controlled. One of my slides talks about active debris removal. Therefore, they have identified 1 or 2 or 3 per year if you remove carefully, and what has to be removed has to be done. And the removal things also I have not highlighted because of shortage of time. Each slide can be given as a lecture by itself of a 1 hour, telling about the importance thing. And already there are a lot of systems in which active debris removal are there. Nets are put, and studies are going on in the space carrying in societies and space carrying nations to contain and net them and bring them. And sometimes, for example, when we studied about human debris, human missions that are there, debris can cause. And therefore, we have how to protect our thing with the debris that is there, how to observe them and remove them from this thing, and how to control them by removing big debris, which has the possibility of generating much more debris by explosions. And to reduce this thing, we have also highlighted various things. All our propellants, upper stage propellants are there. And then we remove that propellant, which can later on explode and cause thousands of small pieces. Therefore, we control it by, after the satellite is launched, the last stage that we has launched, in which the satellite is its propellant, without to remove the possibility of burning in future, we remove them. All those things are, so many aspects are there for the space debris mitigation. And these are briefly highlighted in this thing. And active removal of debris, space debris mitigation, and observing them and cataloging them, and protecting your spacecraft by appropriate coverages there. And these are all the possibilities to contain the negative effect of Mercury. Thank you very much, Satya. So shall we go to the next? Are you listening to me? Is there any second question?
Students, do you have any other questions? Okay, so thank you, sir, for this.
You're okay. Did you call me? Yeah.
Sir, one question from our director, sir.
Yes.
What percentage of debris is expected to reach on the Earth?
That will be okay. That will be
reach on Earth.
Achha. That will be very small percentage. It will be very less because it has to decay. The decay is not coming by natural gravity alone. It is coming because of the interaction with the atmosphere. And therefore, if it is 500 kilometers above, atmosphere is very, very small. That will have a very, very possibility of decay. But in the low Earth, 200 kilometers, etc., where the densities are high, then the possibility is high, depending on the size and the orientation, etc., etc. Therefore, the objects that are there in the very low Earth orbits, 100 kilometers, etc., etc., eventually they may decay. They may decay in 5 years, they may decay in 50 years, etc., etc. Big objects. Very small objects will be left in the orbit that are there. Therefore, it's very difficult to say about the percentage here because it depends on the size and the altitude at which they are there. And therefore, if it is higher the orbit, the possibility is very, very less. Lower the orbit, they can come. And that is why the active debris removal will highlight the areas in which the lower orbit are there, and they can come and hit, and they can put. I have given you a large number of slides, large number of instances in which debris has actually come. But the probability of damage is pretty less, but the dangers are there. And therefore, to contain this thing, we have to mitigate the effect of this thing by removing them or by using the various methods of not creating this thing. For example, earlier launches are there. Once a satellite is launched, the spacecraft is the last final stage whose spacecraft is there. Once it is in orbit, it is shut off. Shut off means inside there's a lot of propellant. And the propellant is such a thing that later on, because of the thermal environment, etc., and the material properties of the casings deteriorate, they may explode and they may cause, it has happened there. And therefore, one of the things that we are following, our organization, Indian Space Research Organization, follows the guideline that we passivate it by remove all the possibility of this thing. And bigger objects, we also bring them back and then bring them back safely onto the Earth. And already existing things, we may have to collect them and bring them back. These are the possibilities. A clear number saying that percentage, it will not be there. Very small thing only will come. And many times they may burn off also because of the high temperature that comes when it is falling. Hypersonic features are there. High temperature will come. Depending on the material property, it may disintegrate and burn off. Once it sustains, a big object only will survive and come on Earth. It can happen, but percentage has to give. It may be of the order of few, certainly less than single digit.
Thank you, sir. So, dear friends, this was an excellent presentation by Professor Adimurthy. Let us thank Professor Adimurthy for his excellent presentation.
Thank you. Thank you very much.